All right, guys, here's FRQ number 5. So very similar to what you're going to see on Thursday here for part A. It says show that dy dx is 3y minus 2x over 8y minus 3x. Okay, so you guys, like, truly try to show that the derivative of that equals that. Don't just make it up and go, oh, there it is. I'll be able to figure that one out, okay? So let's take the derivative here. So for part A, so it starts with x squared plus 4y squared equals 7 plus 3xy. Okay, so we're going to derive each one, keeping in mind that if we derive y, we have to tag on a dy dx. So the derivative of x squared is 2x. The derivative of 4y squared is 8y dy dx. The derivative of 7 is nothing. And then we've got this 3xy. You guys, when I do that, I like to keep the 3 separate. It's a constant. And then I go ahead and multiply by the product rule here, right? That's why I'm putting a parenthesis there. So the derivative of the first is 1 times the second is y plus the first, which is x, and then times the derivative of the second, which is dy dx. Okay? Now, let's do a little bit of cleanup here. So we've got, oops, I got some stuff from like another problem here. Let's erase that so I have more room to do this on. Okay, so I'm going to have 2x plus 8y dy dx equals, I'm going to go ahead and distribute. So it's going to be 3y plus 3x dy dx. Okay? Now, remember, I want the dy dx's to be exactly on the same side. They're on opposite sides of the equal sign, so I'm going to go ahead and move this little guy to the other side. So I'm going to have this 8y dy dx minus 3x dy dx equals, the 3y is still there, but you guys, I don't want this here, so I need to get rid of that, so I'm going to go ahead and subtract it over. Okay, so then factoring out the dy dx, I'm going to get 3y minus 2x all over 8y minus 3x. Okay, now at this point, you should look and see if you got the same answer. So look, I got 3y minus 2x over 8y minus 3x. So if it perfectly matches, you did great. Now look, if it does not perfectly match this, you've got to look at it and go, do I need to flip 2 terms around? Do I need to factor something out? Do I need to cancel something? If that's not the case, you need to look at your work again. Don't just go, oh, I'll just say it equals that and hopefully she won't catch it. I will catch it and you won't get the point for it. Okay, so please don't do what I call magic math and make it magically right. Okay, all right, now let's look at part B. Okay, so part B. Here we have show that there is a point P with x coordinate 3. So I want to show that x equals 3, okay, at which the tangent line to the curve at P is horizontal. So there's really 2 parts to this question. Then I got to do something else here, right? So I need to show that when the tangent line is horizontal, there is an x coordinate equal to 3. Okay, so let's go ahead and do it. In the other problems, you have to find it. They didn't tell you what the actual answer was. At least we know that x equals 3. I just have to show that it equals 3. Okay, so I'm looking at this horizontal thing. Okay, what's a horizontal look like? A horizontal line looks like this. Okay, the slope of that equals 0. Okay, that means that the derivative dy dx equals 0. Okay, so look, let's look at the derivative. Okay, here's my dy dx right here. It's this 3y minus 2x over 8y minus 3x. If I want that to equal 0, I only want the top part of the fraction to equal 0. Remember, if it says vertical, I want the bottom part to equal 0. So I need to set 3y minus 2x equal to 0. Okay, now look, I'm trying to show that x equals 3. Okay, so I want somehow all of these variables to be x's so I can solve for x and show that equals 3. So I need to replace the y, which means I should probably solve this equation for y. If you solve it for x, you're not going to be finding x, you're going to be finding y, you're going to get the other answer. Okay, so if I'm solving for y, I'm going to go 3y equals 2x, add the 2x to the other side. Then I'm going to divide by 3, so I'm going to get y equals 2x over 3. Okay, now what do I do with this? Just like on the other problems, I'm going to take this and I'm going to plug into original equation. Okay, so what was the original equation? The original equation was x squared plus 4y squared equals 7 plus 3xy. Okay, and now look, y equals 2x over 3. That means I'm replacing this y with 2x over 3, and I'm replacing this y with 2x over 3. Okay, it's going to be rather ugly, but you're just going to have to go with it. Okay, so you have x squared plus 4 times 2x over 3 squared equals 7 plus 3x times 2x over 3. Okay, now let's make this pretty. So you have x squared plus 4 times 2x times 2x is 4x squared. And then 3 squared, or 3 times 3, is 9. And then I get that equals 7 plus. And you guys, something kind of cool happens on the other side. The 3's cancel out. Okay, and then what am I left with here? X times 2x is 2x squared. Okay, I'm going to do a little bit more cleanup. So I have x squared plus, this is 16x squared over 9 equals 7 plus 2x squared. Okay, now look, not a horrible equation, but I sure don't like the 9. So you guys, you do need to know how to clear a fraction. If I don't want this 9, I'm going to multiply this fraction by 9 so it cancels out. But look, I can't just do it to 1. If I do it to one term, I have to do it to all terms. So I have to multiply this by 9, this by 9, and this by 9 as well. Okay, so now what's my new equation? It's going to be 9x squared plus 16x squared equals 7 times 9 is 63. And then 2 times 9, that's going to be 18x squared. Okay, let's do a little combining of the like terms. 9x squared plus 16x squared is 25x squared equals 63 plus 18x squared. Okay, then I can subtract 18x squared from both sides. Still combining those like terms, right? So that's going to be 7x squared equals 63. If I divide by 7, I'm going to get x squared equals 9. If I take the square root of both sides, I'm going to get x equals plus or minus 3. Okay, now let's see what the question was. It said, show that there is a point with x coordinate 3. Did x equal 3? It did. It equaled plus or minus 3, but they just want to see that it actually x equaled 3. So indeed, x did equal 3. You just showed that. Okay, now sadly, I'm not quite done yet. What else did it say? It said find the y coordinate of P. Okay, so I found x. I need to find out what the y value is if x equals 3. Now, you guys, you could plug it back into the original equation. I don't want to do that. Look, at the very beginning here, I actually found out what y was. Do you see that? I had that y equals 2x over 3. Let's use that equation. So if I know that y equals 2x over 3, and I replace that x with a 3, look at that. It just equals 2, just what I wanted. Okay? So kind of I don't know, kind of like a spin-off of some of the other questions where they actually give you the answer and you have to find it. All right, now part C. What color should we do this in? Don't know. Let's pick a new one because I'm kind of bored of these colors. How about like this lime green? I don't even know if that's lime green, but whatever. All right, find the second derivative at the point P found in part B. Now, you guys, here's the part, okay? If you could not get point P found in part B, let's say you're like, I don't even know how to do part B. Should you not do part C? No, you can at least find the second derivative. Now you just don't have a point to plug in, but at least you'll get points for that, okay? So don't be like, well, I couldn't get part B. That means I can't do part C. You could still do a little bit of it, right? Okay, do some, get some points, okay? Every point counts on this. All right, so part C. Okay, so I want the second derivative, which means I need to start with the first derivative, which is this little dude right here, okay? So if I derive the first derivative, that gives me the second derivative. Okay, now here is the fun part, okay? I have to derive this. Okay, this is utterly disgusting. It's quotient rule. So I'm going to do low. Actually, you know what I'm going to do? I'm going to move this over because there's no way this is going to fit. Okay, so let's do that over here. Let's do part C. Okay, and I need d squared y over dx squared. I'm even going to like write a little bit smaller. That's how long this is. Okay, so I've got my low. Low is 8y minus 3x times my d high. So the derivative of the high. The derivative of 3y is 3 dy dx minus the derivative of 2x is 2. So I've got the low d high minus, and then my high, which is the top part, 3y minus 2x, times derivative of the low. So the derivative of 8y is 8 dy dx minus the derivative of 3x is 3. Okay, so low d high minus high d low all over square the bottom, and away we go. Okay, so look, I found the second derivative. Now I have to plug stuff in. Yes, you would get a lot of points for this. So what am I plugging in here? I am plugging in this point, x equals 3 and y equals 2. So I am now going to plug in x equals 3 and y equals 2. And I'm really going to hope that I'm going to get some zeros here because I'm not excited about this. Okay, so let's do this. Ready? This is 8 times y, which is 2. So that's 8 times 2. Minus 3 times x is 3. And then times 3, I'm going to deal with that dy dx in a minute. Okay, 3 dy dx minus 2 minus, and then I have 3 times y, which was the 2, minus 2 times x, which is the 3, and then times 8 dy dx minus 3. Again, I'm going to deal with the dy dx in a minute. And then all over 8 times the y is 2 minus 3 times the x is 3 squared. Now, you guys, believe it or not, this is the part where people really mess up. It's because you're nervous, you're going really fast, you're making careless mistakes, so really slow down on that part. Okay, now what have we got? I've got 8 times 2 is 16, 3 times 3 is 9. 16 minus 9 is 7. And then I still have this 3 dy dx minus 2. And then you guys, something like super magical happens. Watch this. 3 times 2 is 6. 2 times 3 is also 6. 6 minus 6 is 0. Hey, that's great news because 0 times this is 0. All of this goes away. That is like music to my ears. Okay, then on the bottom, 16 minus 9. 16 minus 9 is 7, right? And then it's getting squared. Okay, now look, I'm almost there, but I've got a problem. This dy dx, okay? This needs to be an answer like 5 or 7. Or what should the answer really be? It should be negative 2 over 7. There's no dy dx in there. So what does dy dx equal? Okay, well, let's look at it. Let me do a different color again. I don't know, I'll do a dark gray or something. So look, the dy dx from either what they gave you above, or if I can even use this, right, it's the same thing, was 3y minus 2x over 8y minus 3x. Yikes, sorry, let me erase that. 8y minus 3x, right? Okay, but I need to plug stuff in, right? Okay, so I need to plug in x equals 3 and y equals 2. So let's plug that in. Y equals 2 minus x equals 3 all over 8 times y equals 2 and x equals 3. You guys, magic happening again. What is 6 minus 6? It's 0. 0 over anything is 0. That means this guy is a big fat 0. So let's see what we get now. This is 7 times 3 times 0 is 0. 0 minus 2 is negative 2. All over 7 squared, which is 49. Now I'm just going to simplify this a little bit. 7 goes into 49 7 times. So this is going to be negative 2 over 7. Was the answer negative 2 over 7? Oh my gosh, thank goodness. Does that make sense? Okay, and you guys look, even I make mistakes. I make silly mistakes, like when I'm writing the answer key, I miss a negative, or I write a 5 instead of a 3. Like things like that happen. It will happen to you, especially like if you're going fast and you're really tired. So please don't panic about that. That's just like minus a point here, minus a point there. Remember, you're like trying to go for 50% of this, okay? That would be a passing grade, all right? You're trying to get 50% right, all right? All right, you guys, that ends the video.